Okay, so we're moving on to multiplying and dividing rational expressions today. First thing you need to know is that rational is a fancy word for fraction. So yes, we are going to be multiplying fractions again. Of course, we are not going to be multiplying by number fractions, but by algebraic. So let's review. First off, we never want to see this again. I don't want to see you multiply 540 by 32, get a huge number, 48 by 75, and get a huge number. Yes, I understand that when you should have learned cross-canceling in the 6th grade, it was not emphasized, but it should have been. So that means that we want you to look at things in their smaller components. So that means 540 in your mind, you should think, oh, that's 54, so that's 9 times 60. And then 60 can get broken down into 6 times 10. So 9 times 6 times 10 is 540. And then 32 can get broken down into 8 times 4, or 16 times 2, or whatever you see. But you've got to see them as factors. Same with 48, gets broken down to 6 times 8, and 75 gets broken down into 25 times 3. Now I've got their components, their factors, and it can cancel and make this big numbers go bye-bye. Well, obviously, because 9, well, actually here, 6 and 6, goodbye. 8 and 8, goodbye. 3 is contained within 9, leaving me a factor of 3. 25 has a factor of 5, which can go into 10 2 times, leaving me this bottom 5. So do I have anything else that can cancel? No, because on the bottom I'm left with only a factor of 5. And on top I'm left with 3 times 2 times 4, so that's 6 times 4, 24 over 5. So we want to reduce before we multiply. So that means, guess what's back? Factoring. So if you didn't get factoring in Unit 1 and failed that test, and you didn't get factoring in Unit 2 and you failed that test, I told you factoring's not going anywhere. One of these days you're going to have to learn it. So anyway, moving on. These are all the different types of factoring you need to know. So down below we have our rational expressions. We'll start off with the easy one. That's when you are just looking at monomials. So monomials can get broken down into their basic factors. Just like we did on the first page. We were just breaking them down into factors. Now we can cancel any numerator with any denominator. And that's what we have left. We have an x squared left on top and a y. And on the bottom, we have simply a 4. We'll step it up a notch. We can still factor here, but we no longer have monomials. We have a bunch of binomials. So we need to look at our factoring steps. Do I have a greatest common factor? Yes. In this first numerator, my greatest common factor is 3. In my second numerator, my greatest common factor is 5. In my first denominator, my greatest common factor is 2. And in my last denominator, my greatest common factor is 2. Now when I cancel these, there's only one denominator and numerator that can cancel out. Now, what do we have left? Well, we have 3 times 5 monomials can get put together to get me 15. And then we have a binomial of x minus 2 left on top. On the bottom, we have another monomial of 2 and 4, which can get multiplied together to get me 8. And then we're left with x plus 2 on the bottom. And these cannot cancel, obviously, because they're not the same number. This is a number that is 2 less than x, and this is a number that is 2 more than x. So they're not the same number. All right, let's step it up to the harder ones. So here we're dividing. And we should remember by now that to divide fractions, we simply multiply by the reciprocal. So that's the first thing I'm going to do in example 3. I'm going to understand that this division turns into multiplication and that my second fraction gets flipped. Now, what's going on here in the first one? We got a lot going on. First off, I want to look at this negative. If you remember from Algebra 1, when you have a negative exponent, it simply means to flip your base. So in other words, what was the numerator becomes your denominator, and what was your denominator becomes your numerator. So I'm going to rewrite this as 3m plus 6 over 4n minus 12. But that only handled the negative. We still have this squared going on. And a squared means to do it twice. So this is really what this first fraction looked like. Squared means there were two of them. Negative means to flip. So now I can finally go back to my factoring steps. Is there a GCF? Yeah. Let's handle this first numerator and denominator. Let's go to my second. Well, it's going to be the same as the first because there was two of them. And let's come right here. Well, this is trinomial factoring. Becomes n minus 3, n plus 1. And trinomial factoring here becomes m plus 2 and an m plus 2. Now, off to the races. All I have to do is cancel any numerator with any denominator because it's all just a big multiplication problem. So I've got an m plus 2, which will cancel out with an m plus 2. I've got another m plus 2, which will cancel out with another m plus 2. I've got an n minus 3, which will cancel out with an n minus 3. I don't have any n plus 1s. All right, so now let's look at monomials. 3, no 3 on the bottom. So no 4s can cancel, so let's see what we have left. We have left 3 times 3, which is a 9. And then an n plus 1. On the bottom, we have a 4 and a 4, which gives me 16, and then an n minus 3. And for the last one, again, don't make it look hard. Break it down. This is saying divide. It's saying my first fraction is being divided by the second fraction. So this, remember, is called complex fraction. So let's make it uncomplex. We'll rewrite it so that we can understand it. We have this fraction being divided by another fraction. Oh, division just means flip and multiply. Whenever I am multiplying fractions, I look to factor to make them smaller. Okay, this first fraction right here, that's x plus 2. That can't happen anything there. X squared minus 2x minus 3, that's the same thing as this one over here that used n's. And this time it's x's, so it's x plus 1, x minus 3. Okay, let's come over here. X squared plus 6x plus 5, well, that's going to be x plus 5, x plus 1. And down below here, that's going to be x minus 3, x plus 2. All right, what can cancel? Do I have another x plus 2? Yes, I do. Do I have an x plus 5? No, I don't. Do I have an x plus 1? Yes, I do. So after all that, left on top was an x plus 5. And on the bottom, I had an x minus 3 and an x minus 3. Now I can write it as such, or I can be fancy-dancy and write it as x plus 5 on the top, and on the bottom I have x minus 3 squared.